In this fourth episode, we are going to configure loads and boundary conditions. Let's get started. The first thing we will do is set up boundary conditions. Click the support icon from the modeling toolbar, then click New Support Definition button. Give our support a name, pin base, and remove text from RX, RY, and RZ, which stands for rotation about X, Y, and Z respectively. Then press Add. Now we need to apply our new support to the base nodes of our structure. Open the node selection dialog, then click the Geometry tab. Then on Z-axis, put from 0 to 0. Then press the double arrow to create a selection. Next, click on the current selection Edit Control, and the selection will automatically populate. Press Apply to apply pin-based support to the nodes, then close. We can check our support on the nodes table by right-click on the screen, then select Tables, then tick Nodes, then press OK. You can see that our pin-based support has been applied to the nodes we selected. Now let's create some load cases. Click the Load Type button from the modeling toolbar, then start to create load cases. Press Add to add dead load DL1, then change nature to live, then press Add to add live load LL1. Now change nature to wind, label W_EW, which stands for east-west wind direction. Name W_EW as well, then press Add. Do the same for wind in the north-south direction. Then add snow load type as well. Click the Load Definition button from the modeling toolbar to open the Load Definition dialog. Choose one, DL1, from the Load Case selector. Then on the Load Definition dialog, click the Surface tab, then select Uniform Planar Load. Put -0.015 on Z, then press Add. And now we will turn on panel descriptions to obtain description numbers for floor and roof, which are 82 and 83 respectively. Yours may differ. Now enter the roof deck element number in the Apply to Edit control and press Apply. We are going to repeat the same process for floor dead, floor live, snow, and wind uplift on the roof. We can open the load table to verify the existence of the loads we defined by right-click on the screen and then Table. Select loads, then press OK to see the defined loads. As you can see, these are load cases. These are load types, and these are load values applied in the Z direction. Next, we will apply wind loads for the side walls as linear loads at the levels as though there were vertical studs distributing the loads to the floors. Back in the Load Definition dialog, select the Bar tab and Uniform Load. Make sure W_NS is selected in the case selector. Then in the Uniform Load dialog, enter 0.14 for the Y value of the load at the roof, then press Add. Then use the Click to Apply method to apply the load to the windward beams on the south wall. Then do the same for the floor portion of Y, 0.28 keep FT on the floor level beams. Do the same for the W_EW with the same load magnitudes and apply the load to the windward beams on the east wall, as you can see here. In the next episode, we will start configuring basic seismic loads. Until next time, goodbye for now.